Now we have Slater type orbital. What is Slater type orbital? This function is represented as uh, n x to the power a, y to the power b, z to the power c, and e to the power zeta r, where these x, y, and z, these are having a power a, b, and c, which is giving you the angular momentum. N is the normalization constant, and the zeta is the diffuse function. Okay, so for a hydrogen like atom, we can we can use the Slater type orbital because it has not 2p orbital, 2 and 2s orbital, and it has no radial nodes. But when we increase the number of electrons, and we have a multi-electronic species, in those cases using Slater type orbital will be a bit difficult. So in those cases, what we do is, and this is the radial distribution of this Slater type orbital. So what we do is we use Gaussian type orbital. Gaussian type orbital, the function is represented similarly as Slater type orbital, but instead of r, it will be r square here. Okay, and what this gives, enormous amount of application over here. So same thing, that this is the zeta, which and in this case, this is very easy to compute theoretically, and it's this is the radial distribution, and this is the Gaussian type orbital. Gaussian type orbital is kind of, see, if I will tell what is Slater type orbital. Slater type orbital is nothing. This is the linear combination of Gaussian type orbital that will represent Slater type orbital. Okay, that is also known as contracted Gaussian type orbitals. What is that? So before going to that, Slater functions are used in semi-empirical calculations like EHM and semi-empirical methods. Modern ab initio method, we use Gaussian functions. Okay, so what is, first we'll discuss about the contracted Gaussian type orbitals. What is contracted Gaussian type orbitals? So I have already told you that we used to mimic, like, see, Slater type orbital is a bit costly to calculate, so we use Gaussian type orbital. So linear Gaussian type orbital, linear combination of Gaussian type orbital is also known as contracted Gaussian type orbitals. Okay, which used to mimic the Slater type orbital. So actually difficulties are there in STOs, that are STOs are more accurate, but it takes longer time to compute using integrals. Like, way out, we have to use the linear combination of enough GTOs so that we can mimic the STO, right? And unfortunately, a combination of Gaussian to mimic STO is often called as STO-NG basis, even though it is made up of contracted Gaussian type orbitals. Okay. Now, if we see the first one, this is the Gaussian type orbital, or you can say this, the first one, this one, this is the Slater type orbital. Okay, and this STO is not a Slater type orbital. Don't mislead with this STO like Slater type orbital. This is the contracted Gaussian type orbital. Okay, when we have just 1g, so if we are improving the Gaussian this contracted Gaussian type orbitals or the Gaussian type orbitals, it is yeah. So here you can see that if we increase the basis set, it is like mimicking the Slater type orbital. So the linear combination of Slater type Gaussian type orbital will be mimicking the Slater type orbital.